let's talk about how to find critical points for multivariable functions. We know that we have two different types of critical points, one of which being those points where the both of the partial derivative equals 0, and the other one being those where either of the partial derivative does not exist. But no matter which type of critical points we are talking about, those points must be within the domain of these functions. And therefore, finding the domain of this function is the very first important step in solving this question. Otherwise, the points that you end up finding may be outside of the domain, so that's going to be useless work. Okay, so let's first find the domain of this function. The domain is going to be all those points where the inside expression is non-negative, because obviously this function is a square root function. So we're going to have x squared plus y minus 1 squared minus 1 greater than or equal to 0. Okay. And then we're going to take a look what kind of points are in the domain. So we're going to analyze this inequality. We can rewrite it as x squared plus y minus 1 squared, and then move this 1 to the right side, greater than or equal to 1. And this inequality makes us think of the equation of a circle, which is x squared plus y minus 1 squared equals 1. Right? So that is going to be a circle. Let's have this y-axis and x-axis. A circle centered at the point 0, 1 with radius 1. So a circle look like this. Okay, so this circle is x squared plus y minus 1 squared equals 1. But because what we have here is greater than 1 instead of equal to 1, okay? So instead of having just a circle, we actually have more points, which is not only the points on the circle, but also all those points outside of this circle. That being said, the domain consists of points, or the points on the xy plane, excluding the interior of this circle. Okay, so that's going to be what the domain is like. And then after knowing the domain, now we can start differentiating the function to try to find the type of critical point like this and that. So we're going to do a partial x, and then by the chain rule, we're going to have 1 over 2 divided by x squared plus y minus 1 squared minus 1, right? And then multiply with the derivative of the inside function with respect to x, which is going to be 2x. Okay? And this is the partial derivative, and then we're going to set it to 0, solve it. Because the bottom cannot be 0, okay? So in order for this fraction to be 0, we have to have this numerator, which is 2x equals 0, and that gives us x equals 0. Okay? And we do the same thing for the partial derivative with respect to y. Partial y is going to give us 2 square root of x squared plus y minus 1 squared minus 1. Multiply with the derivative of the inside function with respect to y. That's going to be 2y minus 1. Okay. And then we're going to set it to 0. Solve it in a similar way. We're going to have y equal to 1. Okay, so that looks like there's going to be a 0, 1 is going to be the critical point of the first type. Okay, so 0, 1 is a critical point of think that is true, then you're making a mistake here. Because we just said that for points that we're looking at, we must make sure they are inside the domain of this function. So let's check 0, 1, right? So if you put 0, 1 into this inequality, you see that you're going to have 0 plus 0 minus 1, which is going to be -1, right? So it does not satisfy this inequality, which means that this point, although it satisfies both derivative equals 0, it's not a point inside the domain. And we can also see it from the graph here. We just said that the domain is a set consisting points on the circle and outside the circle. But this point 0, 1 is a point that is at the center of the circle, which is kind of inside the circle. And therefore, it's not a critical point by definition. Okay, so we need to cross that out after checking the domain. Okay, so this point is not a critical point. And that being said, there's no critical point of type number 1. Okay, and then we're gonna take a look at maybe there would be some critical points of type number 2. So let's check it. Type number 2 requires that either of the partial derivative does not exist. So let's take a look at the expression of either of the partial derivatives. This is like a fraction, right? In order for a function to not exist, we need to have the function to be not defined. Okay? And then for a function like this to be not defined, we need to either have some problem with the square root or problem with the denominator. Okay? So for example, if the thing underneath the square root is less than 0, then the function is going to be not defined. Or if you have denominator equal to 0, then the function is going to be not defined. So either of those cases. But looking at the domain here, right, the domain expression already guarantees that the expression underneath the square root is non-negative. So that has excluded the first situation where the issue is going to happen with the square root. And that leaves us with the only other possibility, which is when the denominator equal to 0. Okay, when the denominator equal to 0, we're going to have this function not defined. So we're going to take a look at those points. So we're going to take a look at those points, x, y, right, where the denominator is 0. So that is x squared plus y minus 1 squared minus 1 equal to 0. Okay. These points are inside the domain, but in the same time, it makes this derivative, partial derivative, not defined, not exist. Okay, so we're gonna say that this is a set, the set of critical point of type number 2. Okay. So in summary, okay, so the only critical points of this function are the points exactly on the boundary of this circle. Okay. So that is how we deal with this question.